All right, this is for you, those of you who want to redo the states of matter test, the unit we covered right before we went out on for COVID-19 distance learning. So I'm going to try to just quickly review this. By no means is this comprehensive, so you may have to go back and look at your notes and put some of this together, go on the internet to supplement your information. This is what the quiz will be over. Right? So here we go. States of matter. Okay, so we all know states of matter are solid, liquid, gas, and plasma. Solid, just a regular shape. Okay, definite shape, definite volume. We all know what a solid is. Molecules are just packed together. They vibrate, okay, but they're packed together. Okay, a liquid has a definite volume. Okay, but it takes the shape of its container. Okay, so we have some water here. If I pour it into a flask, okay, it still has that same volume. Okay, but of course it's now in a different shape. Okay, so it takes the shape of its container. Okay, a gas, no definite shape, no definite volume unless it's contained. If it's uncontained, it goes out. And then plasma is just high energy gas, so it's electrically charged gas, so to speak. So all tied together with this kinetic theory of matter, which says all matter is made up of tiny particles in constant motion. Okay? So, and as this motion occurs, matter expands. Okay? So if you take a solid, okay, up through plasma, you're increasing the energy, okay, and molecules move faster and faster and faster. Okay? And that brings us into this change of state graph. This is for water. We did quite a bit of this in class, but just to refresh your memory, if you start with something like water, which is easy to demonstrate, you have solid water, which is ice, of course. Right? If you heat that up over time, okay, if you take the temperature of this and it's at negative, say, 10 degrees or 20 degrees, okay, as you heat it up, of course, molecules will start moving faster and faster. When it gets to 0 degrees, okay, then it's going to melt. Okay? And when it melts, it will stay at that temperature at 0 degrees until it's all melted into a liquid. Okay? Where it melts, the temperature is called the melting point. If you go the other way, if you take away heat to freeze it, that's the freezing point. They are the same temperature. Okay? So for water, that's 0 degrees. Okay, that energy, though, let's go back, we're heating it up. That energy to melt it is called the heat of fusion. You have to change it from being a solid to a liquid. It costs energy to do that. That's called the heat of fusion. Then if you take that liquid and continue to heat it up, molecules move faster and faster and faster. It'll expand a little bit. And when you get to 100 degrees, it will start to boil. Okay, again, same concept. As you go from a liquid to a gas, it takes some energy to do that. That's called the heat of vaporization. Right? Okay, to take from a liquid to a gas. You can also do that below the boiling point. That's called evaporation. If I just have this water, which is kind of been melted out here, if I come back tomorrow, it will be gone. It just will naturally evaporate. Okay, molecules get enough energy to escape the liquid phase below the boiling point. That's called evaporation. But here, the temperature at which water goes from being a liquid to a gas, that's called a boiling point. And then, of course, up here you have gas. All right? So that's change of state. That'll be on the little exam I give you. All right? Same unit, states of matter. We got specialized on gases. Pressure is just the amount of force per area. Okay, so we went over that quite extensively. A couple laws with gases, gas laws, Boyle's law. It says that as you decrease the volume, you increase the pressure. Okay, so here we go. We got a balloon, self-contained gas inside here, just air is inside here. If I take that and I squeeze it down to a smaller volume, the pressure is going to go up. Okay? That should kind of make sense to you. Let's look at a mathematical expression of that, which is P1 times V1 equals P2 times V2. That means the first pressure times the first volume will equal the second pressure times the second volume. Okay, so if we have a 1 atmosphere pressure, okay, so P1 would be 1 atmosphere pressure. Okay, if it's at a volume, let's say this is a volume of, I'm going to say 2 liters. Okay, if I then we want to figure out P2, let's say. If I squeeze that down to, let's say, 1 liter, okay, what's the new pressure going to be? Well, you just have to do a little math. Okay, so 1 times 2, of course, is 2. I'll just predict units for a second. Will equal that pressure times 1. Okay, so if you do the simple math there, P2 would equal 2 atmospheres pressure. So, as you can see in this equation, as the volume goes down, okay, the pressure will go up. Okay, so make sure you understand those concepts. Okay. Charles' law, as you increase the temperature, you increase the volume. Okay, so think about hot air balloon. Okay, a balloon, if I take this air in here, if I heat it up, okay, the molecules will start moving faster. That will cause this to expand. Okay, so the way you write that mathematically, the first volume times the first temperature, or over the first temperature, will equal the second volume over the second temperature. Okay, so if this over this, let's say this equaled 2, okay, as you increase this volume, you would have to increase that temperature. All right? Then that brings us into some other fluid principles and laws. Right, Archimedes' principle, buoyant force on an object will equal the weight of the fluid displaced. Okay, so if I have, let's go back to this water right here. If I put this, let's take a ping pong ball, I place it into the water, of course it will not sink. Okay, there's a force pushing up on it. That's called the buoyant force. If I push down, you'll watch that water level will go up. Okay, so what this is saying is that weight of that fluid, how much it went up, okay, that is the force on that object. Okay? You all know if you go swimming, okay, you are lighter. If you took scales, put them at the bottom of a swimming pool, okay, or even in the shallow end, you would weigh less because you have buoyant force pushing back up on you. If you have something a little bit denser, okay, it will sink, but still it will weigh less. Okay, so that's Archimedes' principle. Okay. Pascal's principle is the pressure on a fluid is transmitted unchanged through that fluid. Okay, so a fluid can be either a liquid or a gas. So if I put pressure on this gas here, it's transmitted all the way through. Okay, so think about hydraulics, brakes on a car. When you push on that brake, it goes into the brake line, which creates a lot of pressure because it's going through a small hose. That increases the pressure. Remember, pressure is force per area. Maybe I should have put that up here. Force over area. So if you take that force and put it over a small area, you can get quite a large pressure. Think about a woman standing in high heels. You can put a lot of pressure on that little high heel. All right. So the brake line, you push that down, and it can create a lot of pressure on those wheels. So you can use that to your advantage. Okay, that's Pascal's principle. And then finally, Bernoulli's principle. You increase the velocity of a fluid, you decrease the pressure. Okay, so here's a great example of that is, of course, an airplane's wing here. That creates flight. Here's the cross-section of a wing. As the airplane, let's say, is going this way, airflow is going to hit that wing here like this. Some of the air goes over the top, and some goes below. Okay, the phenomenon is if it hits here at the same time, it hits at the back of the wing at the same time. So that means this one has further to go, so that's going to increase its velocity. And according to Bernoulli's principle, that's going to decrease the pressure. Okay, so on the bottom side of the wing, you're going to have a lower velocity, and that's going to cause an increase in pressure. And of course, that creates the lift. Okay, so that's what gives airplanes the ability to fly. As they go through the air, that it creates a pressure difference that creates lift for the airplane, which of course can be quite substantial. All right, so I hope that's just a review. If you need any more than that, then you can either contact me or research on your own.